Fairly standard. Yeah, thanks for that feedback, Rex. I don't know why that link wouldn't work. I mean, other people have used the link, but thanks for that, Rex. Yeah, so this looks pretty standard as far as the pre-processing, right? It's going to go ahead and separate out the features from the label because the label's our target, right? We know that we want to get to the label. It's going to go ahead and tell Keras that it's a categorical problem that we're trying to solve. It's going to go ahead and give us a train test split where our test size is going to be 20% of our entire data set, which means it's 2,000 records, right? Which an 80-20 split is very reasonable, very common. It's going to scale our data, which is also very common in neural networks. And here really is the key. This right here is the key. This is where like the Keras library really goes to work, right? This is like right here, whether you realize it or not, this is where a neural network is being formed. All right. So remember, quick review, right? I said there were 3 components. There was going to be an input layer, a hidden layer, and an output layer. And I also told you that your input layer is a function of your data, right? The problem you're trying to solve. The middle layer can be whatever you want it to be and however many you want it to be. And the output layer is also a function of the problem you're trying to solve. A yes, no, multi-class, whatever, right? You can see that here, right? Model add. And by the way, I love how it labeled it, right? So this is our input layer, right? So it's going to add to our model this layer, right? There's going to be 64 neurons with the input dimension of 20. In the chat, tell me why there's 20 on the input. Why did it choose that? We didn't choose that, right? Why does the input layer start with a dimension of 20? Yassine says the data has 20 features. Is he right? You can just say, hey, I agree with Yassine. Right? Nobody's going to pick on you. Or you can come up with your own answer. Maybe Yassine's wrong. What do you guys think? You know what? I'm going to hide this. Because I think it's... Okay, cool. That shows more of the code. Yeah. Michael says because it has 20 features, I guess. Yeah. Yeah, they're right, guys. Michael and Yassine are correct. Yeah, Rahul, you know what? As soon as I asked the question, I saw that and I was like, oh my God, but I didn't want to say anything. But you're right. It's in the comment above, guys. Right? It's in the comment above. But yeah, but both Yassine and Michael are correct. And that's exactly what I said, right? It's predetermined. ChatGPT came up with a data set with 20 features. Therefore, your input has to have 20 features, right? So yeah, they're correct. 20 features to 64 neurons. Next is our hidden layers. And now it's telling us that the second hidden layer has 32 neurons. And the third hidden layer has 16 neurons. Anybody have any comments on that? Why would it do that? Why are those numbers significant? Why are there 2 layers? Anybody want to comment on that? Anything jumping out at anybody? Why are there 2 layers? Why are they sized like this? It's divided by k dimensions 20. Okay. Anybody else? Lakshmi says, how it decided to take the number of dents? Yeah, that's the question, Lakshmi. Do you have an answer for that? Hey, welcome back. I'm sorry, I can't read your name in Arabic, but I know you've been here before. Was it Abdelez? I think was your name? Remind me what your name was. I can't read it in Arabic. Ah, Yassine. Yassine is saying it's not actually meant to be like that. It could be any number of layers neurons, but I guess this degradation of the number of features helps in selecting the most significant variables. Okay, from one layer to another. Yassine, my man. Yep, Yassine is right. Remember my previous conversation, guys? Right? I mean, this is kind of a trick question because the answer is it can be whatever you want it to be, right? I said that. That middle layer, the hidden layers, can be anything you want. It can be anything you want. If you guys attended the ISL course, remember how we talked about hypertuning and parameters, right? And how you kind of want that because that's where the experimentation comes in, right? Remember guys? You want that, right? You want to have, as I tell my teams, I call them levers to pull. You want those options. If you had no options, you'd have no experiments, right? So hidden layers is one of those ways that you can tune your algorithm. They can literally be whatever you want. So Yassine is right. It's whatever you want it to be. However many layers, however many neurons. Like that's part of the skill. That's part of your design for neural networks. Right? So there is no right answer. You decide that as a data scientist in your experimentation, in your approach to your problem. Right? Manishegi says you should use leaky rarely to. No. How can you say that? You can't say that. We haven't done any experimentation. You can't say that. I disagree. Totally disagree because what you're expressing there is researcher bias. You have no basis to say that we should be changing our activation function. Sorry, my friend, but that's just plain wrong. You can't say that. You have no basis for saying that. That's not a good practice. Rahul says, so would more layers equal better accuracy? Ah, Rahul, great question, my friend. I love where you're going with this. You don't know. That's part of the experimentation. You don't know. But in theory, yes, right? In theory, right? The theory of neural networks, more processing, more better. In most cases, right? Let me put an asterisk on that. Because there is a little bit of an asterisk on it. But yes, in theory, the more layers you have, the broader the neural network, the more accurate it becomes. Depends on your problem, depends on your inputs, the quality of your data. But yes, in theory, more layers does do better. But again, that's a function of your experimentation.